Welcome to today's session on light. In light, we look at reflection and refraction. So in this chapter, let's look at the lens formula, the magnification, and the power of lenses. So what is lens formula, right? So the lens formula says 1 by f equal to 1 by v minus 1 by u, where f is the focal length of the lenses, where f is the focal length, and v is the image distance. V is the image distance and U is the object distance. So in earlier sessions, we looked at the ray diagrams, right? What is U, what is V, what is F, right? So for example, I have a lens here, right? It can be convex or concave, right? So this is the lens, for example. And if the object is here, and if the image is, let's say, here, then this is the O, the center of the lens. Then the distance between the object and the center of the lens is U, and it is denoted in minus sign always, right? I'll tell you why minus and when to take plus. So here, this is the image distance, that is V. So if you take a positive, if you take this as a coordinate plane, so to the right, let's say this is the x-axis, right? And this is minus x, and this is y. So the image or the object distances, you have to consider the vertical distances, you have to consider positive, and the minus x. So left to the center or left to the lens is minus, and right to the lens is plus values. Okay, so here in object is always in front of the lens, so the object distance is always minus u. Okay, and for convex lens, the focal length is positive. The focal length f, you should always take plus f. And for concave lens, right? For concave lens, you should take the focal length as minus f, right? And for both the lenses, object distance u is always minus u. And the image distance. So image distance depends on the lens, right? So for a convex lens where the image is formed on the other side of the lens. So for convex lens, you can take the image distance as plus V. And for concave lens, which is a virtual image that forms on the same side of the lens, that means on this side, you will get the image. So you need to consider minus V. Understood? So the focal length for convex lens is plus f, and for concave lens is minus f, and the object distance is for both the lenses, it is minus u, because the object is placed in front of the lens, which is to the left of the lens, that is on the minus x axis. So it is minus u always for both the lens. And then the image distance. So image depends on whether it's a convex lens or a concave lens. If it is a convex lens, the image is formed on the opposite side. I mean, on the other side of the lens. So that is onto the positive x-axis. So the V is plus for convex lens and V is minus for concave lens, because the image for the concave lens is formed on the same side of the object. That's a virtual image. So it is minus V. Okay, so based on this, we will do some problems. Then you will understand how to find, if you know a focal length of one lens, focal length, and one of the distance, either object distance or image distance, we can find the other value. So now the basic sign conventions, you got it, right? The lens formula says 1 by f equal to 1 by v minus 1 by u. And the sign conventions I just mentioned. So let's do some problems, then we will know. Right? And also we'll look at magnification. So the magnification m is, there's another formula for that, that is height of the image That is height of the image by height of the object. So we know in the lens, all right, let's say this is a lens, and let's say this is the object, and let's say this is the image. We have different heights, right? Let's say this is object and this is image. So let's say this is h dash and this is h, the height. Then the magnification is h dash by h. Like how small or big the object is. That's the magnification. If the magnification is more than 1, that means it's a magnified image. If the magnification m is greater than 1, suggests that it's enlarged image. You're following right, guys? So it's a bigger image. And m less than 1 suggests it is a diminished image. Right? It's a small image. The length of the image is smaller than the uh, height of the image is smaller than the height of the object. And similarly, the height of the image and object are proportional to the distance of the image and object. So we can also write m as a h dash by h or v by u. You understand? So it's a v by u. So that's m. So that's the magnification. Now, so we learned about lens formula. That's 1 by f equal to 1 by u minus 1 by v, and sorry, 1 by v minus 1 by u. Yeah, let's check it here. So 1 by f equal to 1 by v minus 1 by u. That's about lens formula. And we also looked at the magnification. The magnification is h dash by h, where h dash is the height of the image and h is the height of the object. Or we can also represent this in the form of length of the image, right? Distance of the image by the distance of object. So distance of the image is v. So we can also write this as v by u. All right, so let's do some problems here, right? So using lens formula and magnification, let's solve these problems. These problems are important for the board exam. So focus on these guys. First, what you need to understand is what is given in the problem and what type of lens it is and their sign convention. So I already mentioned for convex, which you need to take plus, and for concave, what values that you need to take minus, right? So here, a concave lens, so that's important. So a concave lens, in a concave lens, we know the thumb rule, right? In concave lens, focal length is minus f and object distance is minus u and image distance is also minus v because image is formed on the same side of the lens. So all the values are negative for concave. Let's see. At what distance should the object from the lens be placed so that it forms an image at 10 centimeter from the lens? Okay, so what is given here? Focal length is given. So f you can write as minus 15 directly, minus 15 centimeters because this is a concave lens. So you can say for concave lens, the focal length is minus. And also what is given? At what distance should the object from the lens be placed so that it forms an image at 10 centimeter from the lens? So V is given. So it's a virtual image. So it is also minus value. So you need to take it as minus 10 centimeters. Also find its magnification. Okay, fine. So at what distance the object needs to be placed? So U we need to find. So as per lens formula, 1 by F equal to 1 by V minus 1 by U. 1 by what is F? Minus 15 equal to 1 by minus V. That is 1 by V means V is minus 10 minus 1 by U. Here the sign conventions are very important, guys. So if you take plus or minus in place of, I mean, vice versa, your problem will completely go wrong. So I'll do one thing. So I'll take this value to the other side. So that means this becomes plus. So 1 by U minus 1 by U becomes 1 by U here. And then this 1 by minus 10, and this minus value 1 by minus 15 means minus 1 by 15, right? If I send to the other side, this becomes plus 1 by 15. So then what is the LCM? LCM for 15 and 10, it is 30, right guys? Hope you know how to find the LCM. So this is minus 3 plus 2, 15 twos. So this is minus 1 by 30. So 1 by u equal to minus 1 by 30, or u equal to minus 30 centimeters. We will obviously get minus value because this is a concave lens. That means the object is 30 centimeters in front of the lens. So if we just want to represent in the diagram, let's say this is the concave lens. So here at 30 centimeters, we have an object. So this distance is u, that is minus 30 centimeters. Then we have an object that is, sorry, the image that is 10 centimeters. So here somewhere we got the image. This is O, I will say. This is I would say. So this distance is 10. You following, right, guys? So this is also minus. So this is how you can find. So the object should be placed at a distance of 30 centimeters in front of the lens. Understood? Now, what is magnification? So magnification M, I said it is V by U, right? So what is V here? V is minus 10 and U is minus 30. So that means, so it is 1 by 3. 1 by 3 means, so M equal to, it's a positive value, plus 0.33 something. So that means plus value suggests it's an yeah, it's so what is the value here? M is less than 1. That suggests it is a diminished image. It's a diminished image, and the positive value suggests it's a erect image. Diminished and erect image. Hope you're following, guys. So these type of problems are very important. They are very easy if you understand the sign conventions. The formula is very simple. 1 by f equal to 1 by v minus 1 by u. For concave lens, just remember it as a thumb rule. For concave lens, f, u, and v all are minus. Understood? Right. And let's look out, let's do one problem on convex lens also, right? So let's look at this. A 2 centimeter tall object is placed perpendicular to the principal axis of the convex lens, right? So for convex lens, what are the sign convention, guys? So convex lens means plus f, the focal length is positive, and object distance is minus u, and image distance is on the other side, which is to the plus x axis, so plus v. So these are the sign conventions for convex lens. Okay, and what is given? A 2 centimeter tall object. So object height is given. So object height, that is h dash. H dash is given, that is 2 centimeters. Perpendicular to the of focal length. So f is given. F is positive, so you don't need to keep minus. So just keep plus. The distance of the object from the lens is, so u is given. Distance of the object. So u is minus. So you should keep minus 15 centimeters. Find the nature, position, and size of the image, also its magnification. Okay, using lens formula. So 1 by f is what? 1 by v minus 1 by u, right? So what are values we know? F we know, which is plus 10, equal to 1 by v we don't know. That's a positive value, so let's keep as is. And then 1 by u is minus 15. So here this sign is very important, guys. So then what this becomes? This becomes 1 by 10 equal to 1 by v. This minus of minus becomes plus 1 by 15. Then can I write 1 by v? Hold on, guys. So 1 by v equal to 1 by 10 minus 1 by 15. Right? So, yeah. Then 1 by V becomes 15 and 10 means 30. This is 30. The LCM is 30. So this is 3 times, right? Minus this is 2 times. So that is 1 by 30. So what is V? We should get a plus value, right? So 30 centimeters. That means if this is the rough sketch and this is the lens, that's the convex lens, right? Then the image, the object is at 15 centimeters. Okay. So U is minus 15 centimeters, right? That is U. And the image is formed somewhere fair. So that is 30 centimeters. Now, if you need magnification, magnification is V by U, right? Yeah, as we know V and U, we can directly use these values. We don't need the height of the object and height of the image, right? So what is magnification? V by U. So then what is V? V is 30 by what is U? Minus 15. So it is minus 2. This sign is important, guys. So magnification is minus 2. We also know M is what? H dash by H. We also need to find the size of the image as well, right? So H is the size of the image. So then minus 2 is, what is a H dash? H dash is 2 by H. So then H becomes minus 1 centimeters. So this minus value indicates the image is inverted. Okay. So here what we can conclude is this is a real image. And because of the minus value, we can say this is inverted image. We know in a convex lens, we get a real and inverted image. And then the size of image is how much? 1 centimeter. 1 centimeter. And what else we need to know? The position. The position is distance of the image. So the distance of the image V, right? So distance of the image V equal to 30 centimeters. You understood, guys? So that's all we can do. So we looked at one problem for concave lens and other one for convex lens. The key here is the sign conventions. For convex lens, it is plus F minus U plus V. And for concave, it is all minus. The focal length is minus, object distance is minus, and also the image distance is minus. Okay. If you keep that in your mind, then it is easy. Okay. All right, guys. Now let's see one more problem, right? A concave lens. Okay. So first thing, okay, it's a concave. So let's first look at the sign convention. That's the thumb rule, right? So the sign conventions are all minus, minus F, minus U, and minus V. Okay. Focal length is given. So what is F? F equal to minus 15 centimeter. A concave lens of focal length 15 centimeter forms an image 10 centimeter from the lens. So V is given. That is minus 10 centimeter from the lens. How far is the object placed from the lens? That means U is asked, and draw the ray diagram. Okay, all right. So according to lens formula, right? 1 by F equal to 1 by V minus 1 by U. What is 1 by minus 15 equal to 1 by minus 10 minus 1 by U. Then uh, okay, so I'll take U to this side. So that becomes plus. Then this is minus 1 by 10 plus 1 by 15. I'm sending to the other side. Now the LCM is 30. So this is minus 3 plus 2. That is 1 by U. That means minus 3 plus 2 is minus 1 by 30. So U is minus 30 centimeters. Obviously, you'll get U as minus. Now, draw the ray diagram. So, ray diagram, how I'll draw is, so this is a lens. So, I'll just draw as a straight line and I'll mention this as concave lens. And the ray diagram, right? You can draw with the scale because we know the distances. You can take to a scale, maybe 2:1 or 1:2, half of it. So the image is forming at 10 centimeters. So with the scale, I can measure 10 centimeters or I can measure 5 centimeters if we are drawing with 1:2 ratio, right? Half of it. So here somewhere I'll get the image. So this is my image, real and inverted. And here I need to indicate V equal to 10 centimeters. Oh, sorry, guys. This is concave, right? Uh, so V is minus, so the image is also on the same side. Then what is U? Okay, so let's say I have the object here, right? I have the object here, and that is at minus 30 centimeters, guys. Minus 30 centimeters. That is U. Then I have a image that is somewhere here, right? That is image. So this is like minus 10 centimeters, that is V. So image is also forming on the same side, and the focal length. So somewhere here you can say focus, that is at 15, right? So that you can say this is F1. Yeah, if F1 is 15, then yeah, I think this is at 2F1, right? And then we can say this is F2 and this is 2F2. Okay, you can draw with scale with like 5, 15 with a scale. Okay, make it half of it because you cannot draw 30 centimeters onto the paper. So you make half of it and you can mention that scale as 1:2. That means you have made it half of it. Understood? All right, guys. So the ray diagram, or you can just draw with a scale and just indicate this is 10 centimeters and this is 30 centimeters. That is also okay. So nobody actually calculates how much length you have used. Okay. But it needs to be proportionate. You cannot say 10 centimeters is bigger than 30 centimeters. Okay. So that much I think you can draw, right? All right, guys. So yeah, remember if it is a concave lens, we have seen number of ray diagrams. The image is also on the same side. Okay, all right. Now let's look at another one. An object 5 centimeter length. Okay, object length, that is h dash. H dash is given as 5 centimeters and is placed at a distance of 20 centimeter in front of convex lens. Okay, so convex. So what are our sign conventions for convex? Plus F minus U plus V, right? Convex. Okay, yeah, so we are not looking at the mirror, so let's replace this with lens. Okay, it's a convex lens. Okay, of radius of curvature 30 centimeter. Find the position of the image and its nature. Okay, all right. So an object 5 centimeter in length is placed at a distance of 20 centimeter in front. So U is given. U is what? Minus value. So minus 20 centimeter of a convex lens of radius of curvature 30. So the radius of curvature means R is given. R is 30 centimeters. That means the focal length is half of it. So F is what? 30 by 2. That means 15. But we should take minus value. So minus 15. Instead of giving the focal length, they have given radius of curvature. So the focal length is half of it, so minus 15 centimeter. Find the position of the image, its nature. Okay, all right. So now here same, use the lens formula, that is 1 by F equal to 1 by V minus 1 by U. So what is F? So 1 by minus 15 equal to V is not given, fine. And then U is given, that is minus 20. So I can write this as minus 1 by 15 equal to 1 by V plus 1 by 20. Then 1 by V, I can do like this. So minus 1 by 15 minus 1 by 20. So 1 by V equal to, yeah, focal length is positive, right? I don't know why I keep writing this, right? This is a convex lens, guys. Okay. only u is minus. So this is 15. So this will also be 15. Okay. So what's the LCM here? 15 and 20. Can we say 60? Yeah, 60. So 15 fours minus 3s. So this is 1 by 60. That means V equal to 60 centimeters. So the image is formed, right, at 60 centimeters away from the lens. So what's the position of the image? That is V. V is 60 centimeters. Its nature and size. What is the size of the image? The size of the image, for the size of the image, what we need to do? We need to find magnification, that is V by U. What is V? 60 by what is U? 20. That means, yeah, this is minus 20, right? So 60 by 20 is minus 3. That means it is 3. It is M is greater than 1 and negative value. That means this is enlarged or magnified, right? So it's enlarged image, enlarged and inverted. As it's a minus value, we can say it's an enlarged and inverted image. All right, guys. So hope you understand how to solve the problems using lens formula, right? All right. Now there's another concept called the power of lens, right? So the power of lens P, the formula is 1 by F, where F is the focal length, where F is the focal length in meters. Remember these, guys. The focal length that you must submit here is in meters. Is in meters. Okay, always in meters. You cannot, if the value is given in centimeters, you need to convert that into meters and substitute so that you will get the power value. So, and the SI unit of power is, SI unit is a diopter. Okay, diopter, or you can represent with capital D. So for concave lens, the power P is always negative because F, the focal length is negative. That's why you get the power value is also negative. And similarly, for convex lens, the power is positive value. All right. So for example, let's say the power is plus 3D diopters. That means this is a convex lens, right? This is a convex lens. And if you need to find the focal length, right? The focal length equal to 1 by P it will be, right? If P equal to 1 by F, then F equal to 1 by P. That is 1 by 3, that is 0.33 meters. That's the focal length of that lens. Now let's look at this problem, right? A doctor has prescribed a corrective lens of power. Yeah, so the power is given, power P equal to plus 1.5 diopters. So plus represents, so he has suggested for convex lens. That's one thing. Find the focal length of the lens. So focal length F equal to 1 by P, right? So that is 1 by 1.5. So that I can write as 1 by 1.5 means, can I write this as 10 by 15? So 10 twos and 10 threes. So 2 by 3. That means 0.67 meters. Understood? So this is a convex lens and the focal length is 0.66 or 0.67 meters. And is he prescribed the diverging or converging lens? So as this is a convex lens, so this is converging lens. So concave lens or diverging lens. You know that, right, guys? Yeah, this is the this type of problem. So when you go to ophthalmologist for eye checkup, so they'll give like a power minus 0.5, minus 1, like that. So when they have written minus 1 means, so you need a concave lens. If the value is minus, that means you need a concave lens to correct your eye vision. If it is minus 1, that means we need a concave lens of focal length 1 meter, right? A focal length 1 meter to correct our eye vision. That's what it means. Okay. If it is plus, then it is convex lens. All right, guys. So yeah, I think we looked at how to use the lens formula and what is magnification and also what is the lens of the power. power of lens, right? All right. So yeah, that's all for today's session. I hope you understand the topic, and I will connect with you later. In case you have any questions or queries, you can connect me using Urban Pro profile. Yeah. Thank you, guys.